Cool, guys. So let us have a very quick look at what we should already know. Like I said, I'm not going to spend long on this. We've done this stuff. If you guys are feeling confused about anything that we do in these next 3 examples, please do go and watch the videos so that you can go and hopefully feel comfortable with it. So we have talked about 2 different types of transformations so far. We have spoken about translations and we've spoken about reflections. Now, translations are sort of the slightly easier ones in that we're just sliding the shape or we're moving it around the Cartesian plane. So either we're going up, down, left, or right, whereas a reflection, we're creating that mirror image that we spoke about in our lesson on Monday. If you were joining us, if you haven't and you're new, that video is on Watobe's website, so you can go and find it there. Okay, so this first example is talking about a translation, and you always follow the instructions given to you according to how they want you to move it. So this is telling me to take the quadrilateral PQRS, move it 3 units down and 1 unit left. Now, basically what that means is that all 4 of these points need to go down and then left. So if we start at P, we're going to go 3 units down, 1 unit left, and where I end up is where I now plot my new point. Now, guys, remember, every time you transform a coordinate, we label it P dash because that little apostrophe illustrates or signifies to me that the coordinate has changed in some way. Now I must do the same thing with all of these coordinates. So Q must also move down 3 units, 1, 2, 3, and 1 to the left. And so Q dash is now at -1, -1. And we do the same thing with R and with S. All right, so again, if any of this is new to you, you need to go and watch the video on Watobe's website that explains it to you. Once you've moved your coordinates, obviously with a ruler, not freehand like I'm doing, you will draw in your quadrilateral. And we have then moved our quadrilateral PQRS 3 units down and 1 unit left. Alrighty. I see your hand up and I know this isn't your name. You're going to have to remind me of your name. I want to say Ashley, but I could be wrong. Your name says Packard.
Yes, ma'am. My name is Ashley, ma'am.
Okay, I remember.
You got it right. But then, ma'am, I just wanted to ask, ma'am, where do you check the past lessons, ma'am, for the for Monday? Because I'm still new to this.
No, absolutely. So if you, Yolanda, you can jump in if I say anything wrong. If you log onto Watobe with like your sign-in details and you go onto their website, you can access all of the videos for grade 8 there. I'll see if I can find a link because I'm pretty sure I had a link at some point, but you can just go onto the website and you can access them there.
Yes, ma'am. Thank you, ma'am.
Okay, pleasure.
Yeah, that's correct. They can just log in with your log details and then you can navigate from there.
Awesome.
Yes, ma'am. Thank you, ma'am.
Pleasure. And then guys, just quickly, just because I've got a date here, there was a question I think Mbali asked, when do sign-ups for the boot camp close? Those sign-ups close on the 20th of October, which is in the Thursday before the Saturday boot camp. So you still have a bit of time. So I'm going to pop it in the chat just so that you can get that date. So boot camp sign-up closes on the 20th of October. Sign-ups close 20. Alrighty, just so that you have it. You do still have some time, so please do sign up. Sejo, do you have a question for us?
Hello, ma'am.
Hi.
Ma'am, what is happening in the boot camp? Are we catching all the work that we have done?
We're basically revising for exams.
Oh, revising. Okay, thank you, ma'am.
Pleasure. Alrighty, guys, so let's have a look at our next example here. That was translations. Like I said, that is literally just moving points or a shape up, down, left, and right. Often what they'll do is they'll give you 2 instructions in one, like I did here. So down and left or down and right or whatever. But as long as you move each of the points according to what the instructions say, you will be absolutely fine. Right, the next thing we spoke about were reflections. Oh, so sorry, maybe I should give you a second to screenshot. I'll wait here for 10 seconds while you take a screenshot, and then we're gonna move on to the other two we've spoken about. Tiamo, do you have a question?
Yes, ma'am. I wanted to ask, is it always going to be 2 instructions, or is there going to be an opportunity to have 1?
So sometimes there definitely will be 1. So sometimes I might just say move it down or move it left, but often it will be 2 and 1, but there definitely can be 1 sometimes.
Oh, okay. Thank you, ma'am.
Pleasure. Okay, so guys, even though I said it's often 2 instructions, they definitely can sometimes be just move it down or move it to the right or whatever the case is. Alrighty, so let's have a look at the other type of transformation that we spoke about, which was reflections. Now, if you weren't here on Monday, that's cool. What we need to know when doing reflections is what we call a line of reflection. Now, the line of reflection is basically where should my mirror be visualized to create the mirror image. So the x-axis in this case is my line of reflection. And so you almost need to imagine it as where the mirror would sit in order to create the mirror image. So my x-axis, remember, is the horizontal one. So this green one that I've highlighted. And basically what I want to do is I want to create a mirror image of this triangle ABC over on the other side of the x-axis. I want to do that flip, that fold, or that mirror image. Now we spoke about the fact that the mirror image must always be the same distance away from the line of reflection. And so if we have a look at coordinate A to start off with, A is on the x-axis. So it's not going to change its position. It's going to stay exactly where it is because it's on the x-axis. And so A dash is where the original A was. However, when I get to B, I can see that B was 6 units away from my line of reflection originally. And so it must be 6 units away from my line of reflection on the other side. And so B dash is going to be at -4, -6. And then finally, C was 5 units away from my line of reflection. And so it should be 5 units away on the other side of my line. And so C dash is at 1, -5. I can now go draw in my triangle. Obviously, guys, you're going to do it with a ruler. It's going to take me too long to try and do that. And so we draw in our triangle using our ruler according to the coordinates I have here. Okay, now we spoke about the fact that when you are reflecting over the x-axis, what happens is that the y coordinates, I can spell, change their sign. So if we have a look at the original coordinates, which I'm just going to very quickly write down, whoops. If I look at now at all of the y coordinates, I can see that they have changed their sign. And I'm just going to get a better highlighter going on here. So all of the y coordinates are the second ones. So the 6, the 5, and the 0. If we go look at the pink coordinates, the y's are now all negative. Now, obviously 0 can't be negative because 0 doesn't have a sign. 0 is 0. But we've spoken about the fact that when reflecting over the x-axis, the y coordinates change their sign. Okay. Again, anything confusing you, do go and watch the video that should be on the website to recap this lesson. I'll give you a second to screenshot this. I see there was a question just to quickly go back to the first question. So I'll scroll back up now for you to take a screenshot, and then we'll have a look at the last reflection that we spoke about. Okay, so take your screenshots. Make sure you have what you need. Right, here's the first question again, just in case you need it. Cool. So let's have a look at the last reflection that we spoke about. Okay, before I do that, Sihle, do you have a question?
Ma'am, on our second question, the second sum, does the line of reflection always have to be the horizontal line?
No, it doesn't always have to be. So in our next example that we're going to have a look at here, I've got the line of reflection as my y-axis. And so in this case, it's now actually going to be the vertical axis.
Oh, thank you, ma'am.
Pleasure. Alrighty, so guys, if we have a look at the third one, it's saying reflect the polygon A, B, C, D, E, F in the y-axis. Now that phrase in the y-axis basically just means the y-axis is our line of reflection, as Sihle has pointed out to us. And so we don't always have to use the x-axis, we can use the y-axis, but basically it's the same thing. I want to now take this sort of L shape and flip it over to the right-hand side. I want to create its mirror image. Now we know that the points must all be the same distance away. And so if I go, let's just start with A. A is 5 units away from my line of reflection. And so on the other side, it must also be 5 units away. And so I can plot my first point, A dash. Okay, I would do the same thing with B, with C, with D, and with E, and finally with point F. Just going to take these bunny hops off here. And once I've got all of my coordinates, I can draw in my shape. Now, guys, obviously I've done it a bit quickly because I can see where my shape's going to be. And draw it with a ruler, not like this nonsense that I've tried to draw here. But basically, as long as all of your points are the same distance away from your line of reflection, you can create your mirror image. And remember, it is that mirror image. It's not identical. It has been flipped. Now, what we spoke about when we looked at our reflections in the y-axis now is we spoke about the fact that the x coordinates now change in terms of their sign. Now, I'm not going to write all of these coordinates down. Let's just do A and B. So A was at the point -5, 2, and B was at the point -3, -5, -3. If I go and look at the new B's coordinates, the new B was now at +5, -3, and the new A was at +5, +2. And so what I can see here that's happened, according to what I've just said, is that if I compare the x coordinates of the original shape to the x coordinates, the x coordinates of the new shape, what I'm seeing is that they have changed their sign. They went from being a negative to a positive. And so this is what I mean when I say the x coordinates change their signs rather. Okay. So reflections is a mirror image, translations is just sliding your shape up, down, left, or right. So I'll leave it there for a second so you guys can take a screenshot. I see Seho's got his hand up, so let's see. Seho, have you got a question?
Yes, ma'am. How did you get the -3 if it gives us +3?
Okay, so remember the y isn't changing, it's the x coordinates that are changing their signs. So this -3 stays -3 because those are the y coordinates. It's the x's that are changing their signs.
Oh, thank you, ma'am.
Pleasure. Okay, so guys, please take a screenshot. I see there's a question to go back to B, so take your screenshots, and I'm going to quickly go up to B so that you can take a screenshot, and then we're going to have a look at our new things for today.
Y'all are doing really, really great. Just it's sort of a pop-up thing. Remember, guys, if you didn't watch all the series, you might actually get lost if you didn't watch all the lessons about transformation. So it will be really, really good for you to spend, your weekends trying to learn and and try to catch up. Okay.
Okay, guys, hopefully you've all got your screenshot of that. I'm going to move on now. If you haven't, you've got like 5 seconds before I go away. Alrighty. Oops, maybe you've got more than 5 seconds. There we go. Okay, so guys, what we're going to chat about today are rotations. Okay, now in sort of grade 8, we only really need to stress about rotations about the origin, and I'll explain what all of this means in a second. So to explain this again, I think it's a little bit easier to visualize when you can see it actually happening. I've got a little video that we're hopefully going to be able to watch. I'm going to see if this works. Okay, we're getting there. Okay, if I, okay, it's just gonna fight with me. It's fine. Let's do this.
Math shorts.
Rotation describes how an object turns around a point. It's used to describe the movement of geometric shapes. For example, if you tack up around the tack, but geometrically, it's the same shape. Rotation is really common. The triangles that make up spokes on this bike wheel are rotating around the center axle. Mathematicians use rotation to describe shapes on a coordinate plane too. Check out this triangle. In mathematical language, we'd show it like this, which describes the points of the triangle's vertices based on where they're located on the coordinate plane. To rotate an object, you first need to choose the center of rotation. This is the point that you'll rotate the object around. To make it easy, we'll choose point 0, 0, or the origin, on this coordinate plane. When we rotate the shape, we need to keep the shape exactly the same distance or equidistant from the center of rotation all the way around. If we rotate the triangle 1/4 turn around the point of origin counterclockwise, keeping the point of rotation exactly the same, then the triangle moves to a different place on the coordinate plane. The triangle shape stays the same, but the triangle has rotated, and the points used to describe the triangle have also changed. To show that a triangle has rotated, we use a little symbol like this. So now we have turned a geometric shape around a point. That's what rotation means. We can use it to move shapes and describe their movement.
Okay, so I know that was like quite a bit of information, and don't stress if you didn't understand sort of all of the terminology in that video. I'm going to explain all of it, but basically what I wanted you to be able to see was the fact that a rotation is moving a shape around in a circle. Now, very importantly, we always need to have our center of rotation, and like I say, what we're going to use is the origin. You can get other points, but it's not important right now, and as long as you can rotate about the origin, you're going to be absolutely fine. Okay, so we're going to start quite nice and easy because this is quite a hard one to tackle. So we're going to start with just one point, and then we'll get into sort of working with actual geometric shapes. Now, guys, I'm going to sort of explain 2 different ways that you can work with rotations. Actually, technically, we'll look at sort of 3 different ways. One of them is sort of using a protractor. Now, a protractor is this instrument here. You all, if you've got a math set, you will all have a You will all have a protractor in your math set. And basically, as long as you know how to measure your angles, you will be absolutely fine using your protractor. Personally, I don't use this method, but that's also my personal preference. I will use another way to do it, and I will show you these ways as we go along. But just so that you know, if you find it useful, you're more than welcome to use your protractor when doing rotations. Okay, so let's have a look at what this actually means. Now, remember, they spoke about, also sort of when I say they, I'm talking about in the video, we spoke about the fact that we want to be able to move the shape around a central point. As I said, in grade 8, our center of rotation is always going to be the origin. Okay, so this point at 0, 0 is always going to be our center of rotation. We have a coordinate here, which is coordinate A at 3, 2. I have plotted that coordinate for you. And we need to go and rotate it according to the instructions. So the instructions say to me 90 degrees anti-clockwise. Now, firstly, what is anti-clockwise? Or we can sometimes call this counter-clockwise mean. Okay. So I don't know if that's shocking spelling. I'm going to try that again. So sorry. Counter-clockwise. Okay, there we go. So firstly, if you imagine a clock, whenever they talk to you about directions of clockwise and anti-clockwise, clockwise is sort of the normal way clock hands would move, sort of, there's a better way to describe this, but my words are failing me. If you imagine how the minute hand moves on a clock, that is clockwise. Anti-clockwise or counterclockwise is then the opposite direction, so the opposite way that hands on a clock would move. So if I'm wanting to move this point A counterclockwise, I'm going to get to the degrees now. I'm wanting it to move in this direction. I've specifically been told to move it 90 degrees anti-clockwise, and this is now why I've said your protractor might be quite useful to you. Okay, I'm going to show you other ways to do it, but it could potentially be useful to you. So we want to go 90 degrees counterclockwise. So we want to go 90 degrees this way. Now, if you think about your Cartesian plane, and I'm just going to take my scribble off, your Cartesian plane is broken up into 4 parts. And if we go back to like our geometry of straight lines, we actually know that all of these angles right in the middle here at the origin are 90 degrees. And so when I'm going 90 degrees anti-clockwise, I'm basically moving from one quadrant to the next quadrant in the direction I've been told to go. Okay. So now if you are someone who likes to use their protractor and would like to do it like that, that's absolutely fine. One way you can deal with this, and one way we're going to sort of start to imagine this, is we can use our protractor. Now, to do this, we know that we need a line to measure our angles. And because the center or the center of rotation is my origin, if I draw a straight line with my ruler from the origin to the coordinate A, I have created a line for myself where I can now put my protractor. Now, I don't think I can put my protractor here nicely. So we're going to imagine taking this protractor and putting it correctly on this line. So remember, you would have to like turn the protractor sideways so that, I'm going to do my best here, guys, so that this line at the bottom is in line with my red line. I'm going to take this off and try and draw this a bit better. So we would take our protractor, and let's get a different color. And I would put my protractor here on this line like that, and I would measure my 90 degrees. Okay, obviously much better than what I'm currently trying to do, but I'm going to get a 90-degree angle over here. Now, what I need to remember is that however long my red line was, so however long this line was, it's gone from bad to worse, it needs to be the same length on the other side. So now
the system is not, it's not favoring you at this moment.
So it needs to be the same length. And this is why I don't particularly like this method, but you're welcome to do it if you want. Once you've got the lines the same length, what you would find is that your protractor would be somewhere like that, and you would be able to plot your coordinate for A. Okay. Now, I don't like that because I find protractors are hard to use. So what I would do is I would imagine a rectangle. Now, I would imagine a rectangle from my origin to my coordinate that I'm wanting to rotate. And the reason I'm saying imagine a rectangle is because if you flip a rectangle that's lying on its side straight up, you've actually flipped it 90 degrees. And so now if I know I need to rotate this rectangle, I can see that this rectangle is 3 units wide and 2 units high. I'm not making the rectangle bigger or smaller. I am just taking it from lying flat to lying upright. So when I now move this triangle to now lie or stand upright, it needs to be 3 units tall. Trying my best, yeah. 3 units tall and 2 units wide. And so what I've done in doing this, I have taken my line or my point, and I have rotated it 90 degrees. And so we always need to imagine that this point is not changing its position on the rectangle. And so when I move this 90 degrees clockwise, this coordinate for A is now going to sit at -2, 3. Right, now I know this was a lot of information and we're going to do more examples. Can I just get a thumbs up, thumbs down of how we feel just with the basics of rotation? You can react, you can put it in the chat, I don't mind. I know it's a lot of information, we're going to do more, but I just sort of want to know where you guys are at before we move on to the next thing. Okay, we're sort of a bit of a mixed bag. That's all right. And guys, like I say, like rotations aren't necessarily the easiest thing to understand. So it's all right. We're going to do more examples. So don't stress if you are feeling a little bit confused or a little bit unsure. It's absolutely fine. We're going to do more. I think before we do that, though, maybe let's take a quick break so that we can get our brains ready for these rotations. We're going to come back to all of these things. Okay.
It's through practice, my peeps. So we see those votes, but through practice, you guys are gonna be fine.
And like I said, I'm going to come back and do the practice now. I know I've just given you a lot of information. So I'm going to give your brains a break. And then hopefully when we come back, it's going to make sense.
Exactly. You've
Okay,
been so nice to us, Teacher Sam.
Okay, guys, so here's your brain break. Remember, we're trying to find the value of the expression here. My only advice is I would say, look carefully at the pictures. That's my hint. Sorry, I had to have a little cough there. Okay, I can already see some hands, which is awesome. Lorraine, do you want to tell us anything to start off with?
Hi, ma'am.
Hi.
For number 1, I said 21 divided by 3 is 7.
Okay, so all of these little caterpillars with the flower on their head is 7. Lorraine, do you agree? Okay, cool. So now we know what the caterpillar with our flower or with the flower on their head is. They're all 7s, and so I've put a 7 there. Now, just be careful. I haven't put a 7 next to this caterpillar because I can see that this caterpillar doesn't have a flower on its head. So we just need to be careful. And that's why I was saying, look at your pictures carefully. Okay. Now, do you want to give us something else?
Well, Miss, I want to answer number 2, which is projector.
Sorry, when you say answer number 2, this is my math stroke. Okay, I've lost it.
Oh, I thought that they wanted to answer the watch, because that's the second part.
The second part, yeah.
Yeah. That's what I thought. Okay, but we have Neo, we have Bunte, we have Nadia. They can help us out. Y'all, what did you get?
Okay, Nadia, tell me something.
Hello, ma'am.
Hi.
Ma'am, for number 2, I say 6 plus 6 plus 7.
Okay, good. So each of these clocks here are 6. Now we need to, again, be careful of our clocks because this clock underneath is 6, but do we all see that the hands of this clock are slightly different? So we need to be careful with that clock there. Just putting it out there. Okay. Lafika, can you tell me or give me anything else?
Hi, ma'am. I would like to answer the final question.
Okay. Well,
Miss,
can you
I
tell us
think
first what the flowers are?
the flower is 2.
Okay, perfect. And so what does
Miss,
that mean the caterpillar without the flower is worth?
the caterpillar without the flower is 7.
Okay, but remember the one with the flower is 7. So without the flower, it would be 5. Because if we take 2 away from 7, we're going to have 5.
Okay. Hang on. Oh. I think the final answer is 29.
Okay, how did you get that? What are you saying that the clock at the end is worth? So this clock over here?
I think that the clock is worth, I'd say it's worth a different, I would say it's worth 5 because the minute hand is at 5 as well.
Good, well done. Okay, so guys, I'm just going to stop you there for 2 seconds just so we can all be on the same page. If you look at the first 3 clocks, the clock is actually telling us the time that it's 6 o'clock. If you look at where the minute and your hour hands is. So now if you look at the second clock down at the bottom here, this is now telling us it's 5 o'clock. So the value of this clock is 5. And so now we have to go and do our working out for this operation. So Lafika, do you want to carry on with this?
It's 15.
Good, well done. So guys, remember we do the multiplication first because that's our order of operation. So 2 times 5 gives me 10. And then I still have to add the 5. So my final answer here is 15. This was a really tricky one. So well done, all of you, for giving it a bash. And it was tricky because the caterpillars, some had flowers, some didn't, and the clock hands were different, and we needed to be careful of that. And guys, remember, if you don't get these, that's cool. It's just like to give your brain a break before we carry on with the next stuff. If you want to take a screenshot, there it is. You don't have to. Like I say, it's just a break. I do see some hands up. So if you have questions, you can leave them up. Otherwise, please please lower your hand and then we will carry on. Okay, so Nkule, do you have a question? Oh, Amanda, I've just seen your message. I need to fix myself.
Ma'am, according to the frame break here, if I see, the flower is not 2 flowers instead of 1.
Yes, I've just lost my marbles. So you agree this should be 4 actually?
Yes, ma'am.
And so this should be 25 because 4 times 5 is 20. Yes. Well done. Thank you for correcting me. Well done. And everyone else who saw that, excellent. I even made the statement of look at the pictures carefully, and then I didn't do it myself. Right. Okay. So let's carry on with our rotations, guys. Oh, I'm sorry if I cough in your ears. So just to recap, the way I'm going to go and explain these sort of rotations, it's through rectangles. I think it's the easiest way to do it personally. There are rules that we can learn, which we'll chat about in a second, but this is the way I'm going to chat about them. So let's have a look at our next example here. So here we've been given the point P. P is at -2, -1. And we have been told to rotate it 90 degrees clockwise about the origin. So this origin point is still my center of rotation, which it's always going to be unless I tell you otherwise. And we now want to rotate it 90 degrees clockwise. Now remember, clockwise is the direction in which clock hands move. So now we're going this direction. Counterclockwise, like we had in this example, or anti-clockwise, was opposite to the way clock hands move. And so this time we're going in a different direction. So again, what I'm going to imagine is a rectangle here. So if we imagine our rectangle from the point to the center of rotation, there's my rectangle. If I look at the dimensions of this rectangle, it's 2 units long and 1 unit wide. And so now when I take the rectangle from its lying down position and I rotate it 90 degrees to stand up, it must be 2 units tall and 1 unit wide. So this is now what I'm going to do. Here's 2 units tall and 1 unit wide. And so I've rotated my point 90 degrees clockwise. These arm movements of mine are quite something to behold. In this movement, remember this point P, and let me get a better color here. This point P must stay exactly where it is. So when I move this point P, it's still going to be on the left-hand side of my rectangle. And so P is now sitting at -1, 2 once I've rotated it. And obviously that should be P dash. Okay, so in imagining a rectangle is a lot easier to sort of work with these rotations as we start to do more and more. Right, before I carry on with sort of my thinking, Mohammed, do you have a question for us? No? Okay. Okay, so guys, what I would like you to think about for a second is what the coordinates are that we're working with. So we know P was -2, -1, and P dash, so the pink one, was -1, 2. And what we can see is that there's some sort of relationship with the coordinates, right? It's the same values, and all we can see is that they've sort of swapped and some signs have changed. So if we go to what a coordinate originally is, x, y, the first thing that I see is that the numbers have swapped here and the fact that the x has become negative. So this is technically y negative x if we relate it back to the original coordinate. And so again, we need to start seeing these patterns to get our rotations as we work with our coordinates more and more. Now, if you don't see the pattern, that's cool. You're going to practice it and you're going to eventually start to see it. But if you can imagine your rectangles, that will go a long way to help you. And so then you don't need to sort of learn or memorize these rules or these patterns. Okay, Mohammed, I can see your hand up again. Do you have a question?
Yes, ma'am, I have a question.
Yes.
On this clockwise something, do we reflect or we're not reflecting on this one?
No, we're not reflecting. So basically what we're doing is we are rotating a point. So almost imagine it as if there's like a piece of string attached at the origin. Sorry, I'm going to try to draw what I'm saying. So imagine that I've got like a pin at the origin and a piece of string, and now I'm sort of moving it in a circle to create a 90-degree angle.
Oh, okay. Thank you, ma'am. I appreciate it.
Okay. Sejo, do you have a question for us?
Ma'am, is it a must like to start with -2 minus 1?
What else would you start with?
-1 minus 2.
But -1 minus 2 is a point down here. That's not the coordinate that I'm working with. So
no,
this.
No, ma'am, I was talking about, you see up there, ne?
Mm-hmm.
The one you wrote in pink.
Mm-hmm.
Yeah, it was -1
mm-hmm.
and comma 2.
Mm-hmm.
And then down you said -2 minus 1.
Yeah.
So the question I was asking is it a must to place it to start with a -2, -1?
Well, I'd have to start with that one because if I take all of the stuff off, that was the piece of information that I was given. And I said to you, take this point and rotate it 90 degrees clockwise.
Okay, ma'am.
Okay.
Thank you.
Sure. Okay, so just to put everything back there. Guys, just so we're all clear, this 2 is from reading off my coordinates. So there's -1, there's 2, so x, y, -1, 2. And that pink point has come from rotating my original blue point 90 degrees clockwise. Alrighty. Makuru, do you have a question for me?
Hi, ma'am. Thank you. I wanted to ask, what happens with the protractor? Because you're using
Sorry, can you
rectangle.
say it again?
What happens when you use a protractor?
Okay, so you can use a protractor here. I personally don't like protractors, but that's also just a personal preference. If you are going to use a protractor, and I'm just going to take my scribbles off again, what you would need to do is you would need to draw a line, so this red line, from your center of rotation to the point you're wanting to rotate. And then what you will do is you will put your protractor on this line, so sort of something like that, if you imagine your protractor there. And you would, okay, that's a terrible protractor. I'm going to try do that again. Something like that. And you would now have to measure 90 degrees. And then as long as you keep these lengths of the two lines exactly the same, where it then ends up at that 90-degree angle, you've got your point P dash.
Okay, thank you, ma'am.
Pleasure. Makuru, I personally, like I said, don't like protractors just because the lengths of the lines are sometimes quite hard to work with, especially when they go to like 3.2 centimeters or something like that. And so if you can imagine a rectangle, I do think it's a little bit easier, but obviously you need to do what's more comfortable. And that goes for everyone, guys. What you are more comfortable with, that's what you need to do. I can't tell you you have to do it like this way because there isn't only one way to do it. You need to decide what you're more comfortable with. Okay, excuse me. Nafika, do you have a question?
Hi, ma'am. On the question, it says rotate the coordinate. That's at -2 and -1. Rotate it 90 degrees clockwise. So, Miss, I was curious why you started at 0. Is that where it's supposed to start originally?
Yeah, so remember, we're rotating it about the origin. So the origin is the point around which I'm going to move the point.
Oh, okay.
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 Cool.
Okay, thank you, ma'am.
Sure. Okay, guys, so take your screenshots and let's have a look at, I would like to do 1 or 2 more, but let's see how we go. Okay. Right, so let's have a look at this one. So this question is telling me to rotate the coordinate M, which is the green coordinate we've got down at the bottom. Sorry, I just want to make that a tad smaller. 180 degrees about the origin. So that's my instruction. We got there in the end. Now, importantly, they haven't told me clockwise or counterclockwise, but that sort of makes sense because 180 degrees is half a circle. So if I think about a circle like that, if that's my origin, so if that's my 0, 0 point, whether I go 180 degrees counterclockwise or I go 180 degrees clockwise, I end up in exactly the same point. And so whenever I'm working with 180 degrees, I don't need a direction because they end up at the same point anyways, because it's half a circle. And so now what I need to do is I essentially need to do this. When I go and rotate, remember, doesn't matter which direction you go in. So whether you go counterclockwise or whether you go clockwise, you're going to end up in exactly the same point. So it really makes no difference. But what we need to bear in mind is that into the next quadrant would be a 90 degrees, but we still have to do another 90 degrees to get to my full 180. Now I would still use my rectangles. I'm not going to change my method here. I'm going to stick to what I'm comfortable with. And so if I think about my rectangle and I draw it in, there's my rectangle, obviously not perfect, but there we go. This rectangle is 3 units wide and 4 units long. So currently it's actually sitting upright. But now when I move it the first 90 degrees, let's try and imagine this for ourselves. When I move it the first 90 degrees, I'm now going up into the quadrant above it, and it's now going to lie on its side. So when I draw in this rectangle, it must be 4 units long and 3 units wide. Okay, I'm doing my best to draw some beautiful rectangles. It's not going very well, but we're trying. So there's my sort of first 90 degrees. So there's a 90-degree rotation. Remember where your point is? My point was sort of at the bottom right-hand corner, which means that now my point M is sitting up here. I'm not done yet. I still need to do another rotation because that was only my first 90. And so now when I go my next 90 to create 180 degrees, we're still going to draw our rectangle. But now my rectangle is going to go back upright. So 4 units long, 3 units wide. It's not a beautiful rectangle, but it's all right. And so I have moved this point 180 degrees. Now again, imagine where M is. M is on this corner, so now it has to stay in its same position at M dash. And this will be at -3, +4 if I write down my coordinates. If I think about the whole transformation, guys, so if you follow my yellow sort of highlighter here, this whole pathway is the 180 degrees. I broke it up into 2 90-degree transformations because that was just a little bit easier to do. But basically, I've moved it all the way 180 degrees. Now, remember, we're not just rotating wherever we want. I have followed my instructions to rotate it 180 degrees about the origin. I've chosen to go counterclockwise. If you had gone clockwise, you would end up in exactly the same position. So it doesn't really matter. Like I said, I find rectangles a little bit easier. And once you start to get the hang of it, you will find the things that make sense to you. But essentially, as long as we are remembering that we are sort of changing the rectangle to either sit sideways or straight up, every time we change it from going straight up or sideways, we're moving at 90 degrees, or we are rotating 90 degrees.